All right, everybody. Welcome. I hope that you had a good chance to work with a partner on your lab reports. If you haven't caught on those lab reports, I am giving you an extra couple of days to do them. They'll be due on Monday instead of Thursday. So you have a week from today to complete them. One thing I want to remind everybody about is the rubric. Make sure that you use your rubrics to check that you've done all the required pieces, right? All the required elements that are there in your lab report. That is the base, right? I mean, you can always put more, but you need to at least have those items. All right. So today we want to talk about stoichiometry, and I do, feel bad that I'm not there to talk you through stoichiometry, so that's why I wanted to make a video of how to do this. It's not overly complex, but the process does take care. All right, it definitely takes care, and so I want to show you the process of doing stoichiometry. Now, before I get into it, I guess I should say stoichiometry. The idea is to take the amount of one thing in a chemical reaction and translate that or convert it, in a sense, into the amount of something else in the chemical equation, right? So if you have a reaction, right? So let's say we have a reaction like this one. Right? If you have this reaction, and I know the amount of, let's say, the methane, right? Let's say it's like 16 grams of methane. I can turn that into an amount of carbon dioxide. I can turn it into an amount of water. I could even turn it into an amount of oxygen, right? The idea here is that if we react this much, right? So if you react this much, right? I can then turn that into figuring out how much of O2 reacts, or I can turn it into how much I produce of CO2, or of course of H2O. I could do either one. I guess I can draw another arrow there. So anyway, how do you do this? Well, the key here is to understand that you can convert based on the chemical equation that you see here, right? Based on the chemical equation, you can convert from moles of any substance in the reaction to moles of any other substance. So for instance, I can say that this reaction involves 1 mole of CH4 and makes 1 mole of CO2. Whoops. Therefore, if I have any number of moles of CH4, let's say I have 12 moles of CH4, right? That would translate into, of course, 12 moles of CO2. We can also see that we make twice as many moles of H2O as we use of CH4. So if there were 12 moles of CH4, that would be 24 moles of H2O, right? So we call this molar ratios, right? And you can write in various molar ratios here. I could have a molar ratio like 1 mole of CO2 for every 1 mole of CH4. Or I could have a ratio of 2 moles of O2 for every 1 mole of CO2, right? And that's just taking note of the coefficients, right? So there's a 1 and a 1 for CO2 and CH4, and there's a 2 to 1 ratio of O2 to CO2, right? So you just use the coefficients and turn them into what we call a molar ratio, and that's what you're seeing over here and here, okay? Now that's the key thing in stoichiometry, right? You can convert moles to moles. Now, what you cannot do, unfortunately, is you can't convert directly from grams of one substance to grams of another substance. So what you have to do instead is if you have grams of something, like 16 grams of methane, right? And I want to turn that, let's say, into grams of water, right? So I'm trying to get to grams of water. There is no direct path from grams of CH4 to grams of water. I can't do that. But what I can do, as I've seen, is I can convert between moles of CH4 and moles of water, right? There's twice as many moles of water as there are moles of CH4 in this reaction. Okay, but I have to get to moles first. I can't just go to moles. I have to get there with a conversion, right? So the first step often in a stoichiometry problem is to convert from grams to moles of your reactant. Now, in this case, it happens to be 16 and change. I'm going to be a little bit simplified in my numbers here, but I use simple ones anyway. So it's about 16 grams of methane per mole. And then, now that I can cancel out grams and I've got moles, right? So 16 grams of methane becomes 1 mole, really, right? Because 16 over 16 cancels. I've got 1 mole of methane. Well, 1 mole of methane, according to the reaction, right? 1 mole of this makes 2 moles of water. So I get 2 moles of water. Okay. And then that tells me then, okay, well, 16 divided by 16 again is 1 times 2 means I've made 2 moles of water for 16 grams of methane. And so then the very last step is to convert 2 grams of water, right? And by now you should know that this is about 18 grams, right? So this would be 18 grams per mole. And so now if you do your math, right, actually moles of water cancel out. We're left with grams of water, which is what we're looking for. And notice that the number comes out to be 2 times 18, which is 36 grams. So what are we saying? We're saying that if you start with 16 grams of methane and you react all of them, you will end up with 36 grams of water. Okay? Now again, you could have done this with converting to CO2. You could have done this with converting to O2 and how much of that reacts along with the CH4. You could have done it in various ways. Okay? All right. So this takes us to our worksheet. In the beginning of the worksheet, this is kind of a walkthrough of how to do stoichiometry. The beginning of the worksheet starts with a sort of step-by-step process of figuring out the molar ratio. And then once you know the molar ratio, you can determine the number of moles that the problem asks for. So for instance, in this one, you're supposed to balance the chemical equation, right? Take a moment, balance the chemical equation. Okay. If you pause the video, great. If not, you should have ended up with 2 there, right? And a 2 here. All right, so it should have been 1 to 2 to 2 to 1. Now, the molar ratio of H2O to Cl2, you might notice, is 2 to 2, or of course, that's also 1 to 1. So you could write that as 1 mole of H2O is equal to 1 mole of HCl. Or another way to write that, of course, is 1 mole of H2O divided by 1 mole of HCl. Okay? Now, I've written it that way in particular because the problem says if you start with 12 moles of HCl, how many moles of H2O will be made? So we start with 12 moles of HCl, and then we use our molar ratio that we just found, so that's 1 mole of H2O per mole of HCl. And you get 12 moles, of course, of H2O. Not very hard math, but the first one was just to kind of get you used to the way to set this up, right? And if you're setting it up properly, you should notice, by the way, moles of HCl will cancel, of course, with moles of HCl, and you're left with the moles of H2O that you want. Okay, so 2, 3 are just like that, and then 4 and 5 don't walk you through it quite as step by step. You have to kind of work it out yourself. All right, once you have mastered that, you'll want to move on to the second step. So if you want to pause the video, do the first few problems, and then come back to the video for this part, great. All right, so you'll notice that I have set up an example problem, right? I've set up an example problem where you were given the number of grams of O2, and you were asked for the grams of CaO that would result in this particular reaction right here. Okay, so look that one over. I think it's helpful, but I'm going to walk you through one of the problems that is on this worksheet as well. Okay, so once again, you have to balance the chemical equation, right? And so if I'm not mistaken, you have to put a 2 there, and I think that might be it, right? 2 H's, 2 H's, 2 Cl's, 2 Cl's, Ca, yeah, that looks great. Okay, so we've got a balanced chemical equation, and then it says, all right, you need to start with 12 grams of HCl, and from that, figure out the number of grams of H2O. And I like to set it up like so, all right? By the way, I call these triple T charts. Okay, you can kind of see why, right? There's 3 T's in them. And that also reminds me, of course, that I'm going to have 3 steps in this process. The first step in every case is dividing by the molar mass, right? So you have to divide by the molar mass, in this case of HCl, right? And you can figure out what the molar mass of HCl is. I'll leave that up to you, right? The second step is to use the molar ratio. So you figure out the ratio of moles of the thing you're looking for, in this case, moles of water, right? To moles of what you already had, which is the HCl. Now, looking at the chemical reaction, you can probably figure this out pretty easily, right? There's a 2 in front of HCl. There's a 1 in front of H2O, or at least an understood 1, okay? And then finally, the last step is multiply by the molar mass, right, of what you're going for, in this case, H2O. And again, I'll let you figure that out. But I like to start it out by setting everything up, right? Setting everything up, you've got 12 grams of HCl, you divide by grams per mole, that'll give you moles of HCl, you turn moles of HCl into moles of water, and then you turn moles of water into grams of water. So it's a nice 3-step process. Okay, if you haven't figured out yet what the molar masses of these 2 things are, you might recall this one's, water is, 18.015-ish or something like that, right? And HCl should be, I think it's 36.46 grams per mole, okay? Don't take my word for it. Figure it out for yourself if you're not sure about that. But here I want you to notice something, okay? My grams cancel, my moles cancel, my moles of water also cancel, and I'm left with, of course, the units that I'm looking for, so that's good. You want to make sure that that's the case. And then the last thing I like to do, besides just plug, of course, everything into the calculator, is check that the math makes sense, right? Like when you get an answer, you should get something that makes sense. Well, here I've got 18 over 36. Well, 18 over 36 is 1/2, right? So 1/2 times 1/2 is 1/4, and 1/4 times 12 should be about 3. So if the answer you get isn't close to 3, you got a problem, right? And I believe it turns out to be a little less than 3, right? Just a little less. Okay, so that is the process for mass-to-mass stoichiometry problems. Okay, work out the rest of these problems, and of course, let me know if you come across any issues. All right, I'll talk to you on Thursday.